right triangle trigonometry. So basically, I call this the one where you have to solve for every angle and every side. So with a right angle in a triangle, you have to solve for angles and sides. You're given 3 pieces of information and have to solve the other 3. The values of the trig functions of an acute angle are the ratios of the length of the side. This way of viewing the trig functions leads to many applications and in fact was the point of view by early mathematicians before calculus in studying trigonometry. And then there's some word problems. Now your objectives are I will be able to find the trig functions of acute angles using the right triangles. So in particular on that, we're going to do our sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So that's going to be your ratio of side length in a triangle. Now you might also have something like find the angle when this is 3 and this is 4. So it's going to be like, well, what trig function is that? Well, this is the opposite, this is the adjacent. And so based on opposite over adjacent, you have to use tangent. Now based on needing the angle, we have to do tan negative 1. And then we have to do 3 over 4. So then you'd have to be in degree mode. So go to degree and then do tan negative 1, 3 over 4. That gives me 36.87. So we'd probably say 36.9 degrees or 37 degrees. Because most of the time they tell you round to the 10th. There are a few times where it says round to the whole number. So that's the idea behind it. Now, use the complementary angle theorem. Well, that has to do with sine and cosine, and we'll get into that. So a triangle in which one angle's 90 degrees is called a right triangle. Recall that the one across from it's the hypotenuse. Other 2 are called the legs. Normally angles are with a capital letter and sides are with lowercase. So say you have this triangle A, B, C, then this one would be little a, this one little b, and this one little c. So A, B, and C are angles, and little a, little b, little c are sides. So there's your description of it. Now before deciding which one is adjacent, you probably got to find out the hypotenuse first, and then the adjacent one is next to the reference angle. So if you have a triangle like this, here's your angle. Well, they're saying, well, first, which one's the hypotenuse? Is it this one or this one? Well, I wonder. If this is your 90-degree angle, then this is your hypotenuse. And then this is your adjacent, and this is your opposite. So that's what it oriented that direction. Now if you're oriented the other direction, here's your angle. Well, you know, there's your 90, so this is your hypotenuse. Here's your opposite, here's your adjacent. And then if we do one like this, here's your opposite, here's your hypotenuse, here's your adjacent. If we do one like this, here's your opposite, here's your hypotenuse, here's your adjacent. So there's all 4 combinations. Okay, so if we're saying C is the right angle, then, what they're saying is that theta is angle B. So that means if here's theta, they have it like that, which means little a here, little c there. So that's what they're talking about when they say this assumes theta is between a and c, little, like lowercase, and across from b. So then based on that, sine would be b over c, because that's your opposite over hypotenuse. Cosine would be the adjacent over hypotenuse. Tan is opposite over adjacent. Cosecant is the hypotenuse over the opposite, which I would probably just say 1 over sine, because that's easier. Secant, you'd probably think is 1 over cosine, and cotan is 1 over tan. Now, cofunctions are equal when it's complementary angles. This means they add up to 90 and it involves the partner. So examples in degrees are these. So let's prove that. So if we're in degree mode and if I do sine 30, that's a half. If I do cosine 60, that's a half. So basically the way to think of it is cosine of 90 minus 30. And this one is cotangent of 90 minus 40. So we have tan 40. Whoops, that didn't reduce. I should have hit Control Enter. And then cotan 50. Control Enter, same thing. So that's how these work. So this is, wait, now that one looks a little weird. It actually may be right though. Let's double check. Secant 80, cosecant 10. Yeah, it was right. So this would be like cosecant of 90 minus 80. So that's how those are related. And then here's your Pythagorean theorem. And so, C is the square root of a squared plus b squared. It might be useful if you do function 1 is x squared. It goes 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, 49, and so forth. When I was in school, we went up pretty high. 864, 900, I'm sorry, 981, funny, 1000, let me just keep going. 11, 121, 12, 144, 13, 169, 14, 196, 15, 225, 16, 256, 17, 289, 18, 324, 19, 361, 20, 400, 21, 441. That one I'm going to double check. Yeah. 22, 484. I think. Yeah. 23 is 576. No, 529. Missed one. 24 is 576. Yeah. And 25, 625. And then we also had to memorize 36. For some reason, it's kind of random, but it's 1296. 36 squared is 1296. So that's my background. We had to do that on paper without calculators, timed. So try that on for size. Okay, but what you could do, like I'm saying, is do F1 is x squared. X squared. Then just go to your table. And there they are. And remember how it's related is if you do the square root of the big number, then you get the small number. So that's how it's related. The other thing is like sometimes you might want to do something like 36 divided by x. I know it's a rational function, but I'm not using it in that respect. What I'm doing is I'm saying in my table, how do you get 36? You go 1 times 36, 2 times 18, 3 times 12, 4 times 9. Now on this one with 5, it's 7.2, so you can't factor using that. And then 6 is 6, and then it repeats. You know, that doesn't work. 8 is 4.5, 9 is 4. Okay, so earlier we said 4 is 9, and now it's saying 9 is 4. So anyway, that's kind of useful when you're trying to reduce things, like reduce your square roots. Because you could say, you know, technically, well, you can just reduce it easier if you know that stuff. 12 times 3 and so forth. Okay, so here we go. Determine if it's true or false. In a right triangle, if two sides are known, the triangle can be solved. Well, let's make up an example. Okay, so I'm going to call this capital C, so this is little c. I'd have to do my Pythagorean theorem to get that. And if you type that in, you get 25. If you do it by hand because it's faster, you get 25. Then C would be the square root of 25. Okay, so we have that, and we know this angle. So if you want to write down your givens, what I'm given is that B is 3, capital C is 90, and little a is 4. Given 3 pieces of info. And then you find the others, and so in this case C is 5 is our first answer. Now how would you find A? Well, to find A, you would either do opposite over hypotenuse, which means you're going to use sine, and we would say A is inverse sine of 4/5, or you would use the adjacent over hypotenuse, which means you'd use cosine I mean cosine B. Which is 4/5. So if you do inverse cosine, I just goofed up because I was being too prideful. I bet it's inverse cosine of 3/5. inverse sine 4/5 is of 3/5. So this is cosine A is 3/5. Now on my teacher calculator, it converted it, but we would have said basically 53.1 degrees. And if we did this as a decimal, that's also 53.1. Now, now we just found angle A. Now, how do we find B? Very easily. 90.0 minus 53.1. So 36.9. So then I'd put 36.9 degrees, and I put 53.1 degrees. So on a 3, 4, 5 right triangle, it's not 30, 60, 90, it's technically 37, 53, 90. Okay, so there I'm just showing you can do it. You can do it. Okay, now the problem is if you know the two acute angles, you cannot solve it. Like, what if we did the 30, 60, 90 thing? Well, I don't know any side. So, can't find any side. So that's why that's a false. Now, if we know one of them and we know the right angle, then we could have figured out 60, for example. But if we're not given any side, then, we're out of luck. Okay, now for this one, find the value of all of them. And so this is little b, which means this is b. This is little a, so that's big A. This is C, and that's C. Okay, so if you have 10 for A, and you have 7 for B, how can we find C? Well, the easiest way is the Pythagorean theorem. So 10 squared plus 7 squared equals C squared. 100 plus 49 is C squared. 149 is C squared. C is the square root of 149 the square root of 149 is 12.2. Now, I'm just doing that for information, and I'm going to say approximate. It's really square root of 149. You need that in order to do your sine, cosine, tangent. Okay? So this is the first step. Do the Pythagorean theorem. And we would use the 149 part with the square root. Now, the second step would be that sine is the opposite over hypotenuse. And so that'd be 7 over, well, we call it B over C. It's basically 7 over square root of 149, which could be counted right in Math Excel, but it's also this. So remember, if you don't like having it that way, they call it rationalize, where you put the square root on top and on bottom, and then multiply straight across. I'll just put it here, 7 squared root of 149 over 149. The reason why the denominator one doesn't have the square root is you multiply straight across. A square root times a square root is a whole number. So this one's a whole number. So that's how you get sine. Now for cosine, it's the adjacent over the hypotenuse. And so the adjacent is where, all this, again, just like in my notes, I said, say B for these. Cosine would be the 10 over square root of 149, which is the same as that. Tangent would be the opposite over the adjacent. And so we'd call that the 7 over the 10. And then secant would be like 1 over sine. Or you could take a step and say, if sine of B is 7 over square root of 149, then cosecant is square root of 149 over 7, since it's 1 over sine. Now, if you refer to those other notes, we could have even said it's the hypotenuse over the opposite. I don't use that approach as much as like, well, what was sine, and then flip it. But do whatever you prefer. If I continue on that same path, secant is 1 over cosine. Now cosine of B was 10 over square root of 149, and so secant is 1 over cosine. Well, I already did that. So that'd be square root of 149 over 10. And for those counting at home, as a joke, hypotenuse over adjacent. And this one, adjacent over opposite. So basically tan, it's 1 over tan, basically. These are the reciprocal identities. Remember? This shouldn't be new to you. And then if tan of B was 7/10, then cotan would be 10 over 7. So there you go. Now on this one, they use the 13 and the 26. Well, let's call this x. And I'm going to say, do your Pythagorean theorem first. X squared plus 169 equal 26 squared, 676. And then if you're typing that, and if it is blinking here, hit minus. It says answer minus, and then we want 169, 507. So x is the square root of 507, which I know doesn't reduce, but if you reduce by 9, that doesn't either. Actually, I don't see a way to reduce that. Okay, now when we're getting our angle, we'd probably say adjacent here and hypotenuse here. The adjacent over the hypotenuse is the cosine. So because of that definition, we'd have to say cos negative 1 of 13 over 26. Wonder if 13 is divisible by 26. It is. It's a half. There's the half. So in order to find that, we'd look at your unit circle, or by now you may remember that. That's if the inverse cosine of 1/2, that'd be 60 degrees, or pi thirds. And then the other one would have been 300 degrees, or 5 pi thirds. Now again, technically 5 pi thirds is the same as negative pi thirds, because forwards 5 pi thirds is the same as backwards pi thirds. Now, all that to say, if we have inverse cosine of 1/2, then that is equivalent to this. And this is the one with flipping cosine. So those should be your first answers. And then the next one would be do your opposite over hypotenuse. So the opposite is x. Well, since we figured out it's the 60 degrees, on the unit circle, you have the ordered pair 1/2 comma square root of 3 over 2. So that means cosine is 1/2 and sine is square root of 3 over 2. So that's how you get this answer. And then if you flip the sign, then that'd be 2 over square root of 3. And 2 over the square root of 3 can be simplified into 2 square root of 3 over 3. And then for tangent, that's the opposite over adjacent, or some people say sine over cosine. So you're basically doing square root of 3 over 2 divided by 1/2. So then you change it to times 2, it cancels, and you just get square root of 3. And so then cotangent would be 1 over square root of 3. And if you rationalize that, that'd be square root of 3 over 3. Okay, so that's how all those work. That's a good stopping point for this video. Hope that helps.